Good morning, everyone. So today we'll talk about the number of factors. Today's lecture is based upon the entire discussion for how do we calculate the factors, number of factors, and what are the various significances of learning that. Let's take an example to illustrate. If I talk about 12, I assume everyone knows the fundamental definition of a factor, a number which divides this given number completely. So what all are the various factors of 12? Let me jot down. What are the various factors of 12? 1, 2, 3, 4, yes, what else? 6 and 12. These are the various factors, or in other words, these are the various numbers less than 12 which divide the number completely, and 12 itself also divides it. So how many factors in total? 6 factors? Yes. Similarly, let's take one more example, 100. So in case of 100, what are the various numbers less than 100 or equal to 100 which divides 100 completely? 1, 2, 4. Can I write 5 as well? Yes, of course. 10, 15. No, I cannot write 15. So 20, 25, 50, and finally 100 itself. So lowest factor is always 1. If you have seen in both the cases, the highest factor is always that number itself. So how many factors? 9 factors. Now the question arises, if I have to calculate the number of factors, do I need to write down all the factors every time and then count it? Imagine if you have a number as big as 10,000 or more than that, can you afford to write down all the factors and then count it? No, not possible there in the exam. You will be able to solve only one question. I have to solve one question in 48 seconds, not in 48 minutes. So keeping that in consideration, so let's devise a trick to calculate the number of factors. Let's factorize 12 into its prime factors. So can I write 12 as 2 square into 3 to the power 1? Of course I can. So if I factorize 12 as 2 square into 3 to the power 1, how do I calculate or how do I use this factorization to find out the number of factors? Now look very carefully. What is the first power of the first prime factor? 2. Increase it by 1. What do you get? 3. What is the next prime factor? 3. But what is the power? 1. Increase it by 1. 2. So the prime factor, the value of the prime factor does not matter. What matters is the power of the prime factor. If you increase it by 1, you get 3 into 2, 6. Some of you might be wondering why I am doing it. Very logical. If you just look at it carefully, what are those powers of 2 which divides 12 completely? 2 to the power 0, 2 to the power 1, 2 to the power 2. These are the three powers which will divide 12 completely because the highest is 2 to the power 2. Similarly, what are the various powers of 3 which divide? 3 to the power 0, 3 to the power 1. All the combinations of these three with these two will give you the various factors. So that's why I'm multiplying 3 into 2, 6. Similarly, now the question arises, can I do a similar exercise for 100 also? Of course, yes. What is the factorization of 100? 4 into 25. So can I say 2 square into 5 square? It is not necessary to write down 3. Of course, you have to just factorize the number into its prime factors. Now if I increase these powers by 1, if you increase these powers by 1, so how do I use the formula now? First power is 2. If you increase it by 1, what do you get? 3. The next power is again 2. If you increase it by 1 magnitude, so you can get 3. So 3 into 3, 9. How many factors you had? 9. I hope it is cleared. How do we calculate the number of factors of a number? Very important point. Now just look at it. Number of factors of 12 is 6. And then the number of factors of 100 is 9. Can you deduce something very important from here? Number of factors of 12 is 6, whereas the number of factors for 100 is 9. This is odd and this is even. Can I deduce something important from this discussion? Yes, I can. 100 happens to be a perfect square. So can I say a perfect square will always have odd number of factors? Yes, I can say that. Very, very important point. A number which is not a perfect square will always have even number of factors. Again, there is a logic behind it. A perfect square will always have even powers of all the prime factors, may it be 2, 4, 6, whatever is the power, it will always be even. That is why it is a perfect square. The formula says you have to increase the power by 1. Now if these are even increased by 1 will give you odd, and product of odd will always remain odd. So that's why I can say a perfect square, very important point, a perfect square will always have odd number of factors. Do remember that point. Very, very important point. Right? A perfect square will always have odd number of factors. In the next video, we'll talk about product of factors, sum of factors, and how can I use this fact of even and odd to answer various puzzles. I hope you enjoyed the video. For any queries, you can get in touch with me anytime on my email address pkbansal.nit@gmail.com. Thank you.